All right, guys, we'll get started with the next session here. Up next, we have a presentation, Vexed by Vulnerabilities That Don't Affect Your Product. Try this. This is by Allan Friedman from CISA and Thomas Schmidt from BSI. And with that, I'll just turn the stage over to you guys and we'll get started. TLP white, just like the last couple of sessions we've had in this room. And if you have any devices, please turn those audio indicators off.
All yours, Jeff.
Slides. Good morning. Thanks, everyone, for abandoning your coffee to come up. So very briefly, who we are. We nerd wrangle in various components. Thomas is the ICS cowboy. If you've not seen his picture in the program, he's clearly and emphatically a white hat, very large white hat, who's been working on the how do we automate security in the OT domain. He actively avoids, he doesn't just passively avoid social media, he actively spurns it. And he's the lead for CSAF. I'm happy to say that I know a decent number of you. I'm Alan, I'm the guy who doesn't shut up about SBOM and related issues. So I'm the nerd wrangler for SBOM and what we're gonna be talking about today. So a couple of caveats. This is something that is still being cooked up in the lab, but we think there's plenty that we can sample today. So there's a horrible cliche in cybersecurity of building the plane while flying it. That is very much the reality here. But one of the things, what we're going to talk about today is actually being used and paid for. Right? There are paying customers who are using this today. So what are we talking about today, Thomas?
It's basically the blowover of Log4Shell. So we worked on that before, but that really gave the drive when we looked at the vulnerability of Log4Shell and the subsequent ones. So basically, when you have a vulnerability like Log4Shell, what do you do? So first of all, you need to know which of my products are affected and what are the mitigations. And now you need to know where to find that information and potential ways to find about products at risk or security advisories. You could ask your vendor, you could do your own investigation, or you have a look at your SBOM. And if it comes to that, you want to know how many vendors do you have, since you have to check all of them and all of their products. So if we are going to look onto their websites, it probably looks more or less like this. You got a really lot of websites which you have to go to. But then if we come back to our potential ways of finding our products at risk, we see a bunch of problems there. So security advisories, yeah, maybe the vendor hasn't issued one. Or if he has issued one about a vulnerability, is your product in there? Is the product that you care about mentioned in it? You could ask the vendor, so...
They love it when you call their helplines, don't they?
They do, totally. And you get a support ticket number and you don't know what to do. So still no answer from the vendor yet. So maybe you want to start your own investigation, but just having looked at the slides, how many vendors you have, that might be very time consuming. And then the question is, where do we start? Where do we actually prioritize our products and do our own investigation and not wasting time when the vendor 5 minutes later published a security advisory saying, hey, I'm affected. Yeah, I found that out 2 days later. So then the question is about SBOM. Do you have it?
Careful.
If you have it, perfect. And then the question is, does it have enough details? If it just have one, the depths of one, you might not even see that there is somewhere in the library that includes a library in the library that there is log4j in it. So the question about the number of vulnerabilities, I can't really answer, since you have today, the vulnerability management is something you have to do day by day. But I had a look at the CVEs, and more or less they are rising. I couldn't say that's exponentially or polynomial, but they are rising over time.
We can ask Jono here to do the math for us. So, and also, it's not just the total number of vulnerabilities, it's our awareness of them. So SBOM is going to tell us about the maximum number of potential vulnerabilities. As we have more visibility into our supply chain, That is going to be very helpful for us in the long run, but in the short run, it's going to give us more things to worry about and more things to do. Now, that doesn't mean that we should ignore it. Let the record show that Allan is still solidly SBOM, pro-SBOM. But we want to make sure that we're going to have all this data going on. So what do the folks that are actually managing the risk for their customers, for their users, what do they want today? Well, SBOM is definitely something that everyone wants, but today we may not have the technology to actually use it and analyze it today. We're working on it. There's just an open source project that was announced called Daggerboard by a hospital, and if a hospital can learn how to use SBOMs, then surely a lot of the more mature organizations can as well. But what are the problems we're trying to solve?
So basically, we have seen the numbers of vulnerabilities arising. And SBOM adds to that overload. So we need to solve the problem of scalability, and then we need to solve the problem of exploitability, since not every vulnerability really can be exploited.
So one of the things is, if we talk about sort of real vulnerabilities, right, we want to focus on the things where bad guys can do bad things. We're not chasing down vulnerabilities just for the sheer pleasure of hearing the bing once you've patched something, right? We need to focus on protection. We want to minimize the number of things where we just are uncertain, hey, is this vulnerable or not? And we, of course, eventually want to have some data so that we can track it, perform it, maybe use that dreaded compliance model. So if we're talking about what bad guys can do things, the traditional model is exploitability, right? CISA has announced the known exploitable vulnerabilities, where we say, hey, these are the stuff that we know the bad guys are already using. But as Thomas mentioned, not every vulnerability is the same, certainly not when they're baked into a product, right? So we don't use the term exploitable, because debating what exploitable means is roughly as much fun as debating which text editor is inherently superior. It's Emacs, by the way. We agree on that.
Oh, we are.
Yeah. So we define this from the user's perspective, thus to say, rather than saying it's exploitable, it's, am I affected? Do I need to do literally anything? So the action for being affected could be, I need to patch, but it could also be to verify a setting. So when I sold Thomas a blinking box, I said, do not, under any circumstances, plug this directly into the public internet. Always needs to sit behind something. If the vulnerability is only exploitable if the blinking box is published and plugged in the internet, Thomas still needs to go and make sure that no one in his team did something very stupid. So that's still a check. So we define affected as do need to do literally anything, and that includes a basic config check. The complement, this is what every security team wants to know, is I'm not affected. I literally don't have to do anything about this. And we'll talk a little bit about why that might be the case. So at its core, there are going to be vulnerabilities that simply do not affect a product based on how that code is used. So what are we going to call this? We're going to call it VEX. I apologize for the dumb name. That's my fault. This was a temporary placeholder name that we used as we were talking about it. And some of you might know that there's nothing in the world quite so permanent as a temporary government idea. And so we're sort of stuck with the name VEX. We get lots of puns. If anyone can come up with a new one, I'll buy you a beer. Then the goal here is to make the product status explicit. And, more than just saying it explicitly, make it machine readable. Because again, in 2022, if you're building a security system without aiming towards automation, you're wasting everyone's time.
So what are the use cases? So we have seen Log4Shell as another media hype vulnerabilities, and those where you actually have your CEO on the line and they're calling you up in the morning or in the evening whenever they have time, and asking you, what's the status? Which of our products are at risk? What have you done? Report back immediately. And then you have to do a lot of work and still report to your superiors. So it would be easier if you have some tools that assist you to do that work. We also have the problem of false positives in security scanners, the OpenSSL 0.9.8, where it every time reports you, oh, that's vulnerable to hot lead, but the hot lead function isn't in the product at all. So there is no point of patching vulnerabilities that aren't even there. And then you might have an in-depth security analysis of a product actually looking into what is there in the product from the CVEs I called from the NVD or from the CVE project.
So how do we think about organizing this? Well, there are a couple of different ways. We're not trying to be explicit and directive at this stage. We think this is something that we want to find out how the market's going to use. So you can have this model with one product and one vulnerability. You can have this product, you can have a VEX where it references many products and one vulnerability, right? This is the response to your log4j style vulnerability where you just say, hey, here's all of my products, here's all the information. And we can also imagine a world where we can reference many vulnerabilities about one product. So this could be coming, and I'll talk a little bit more later about how VEXes can come from anywhere. Anyone can publish a VEX. So we can imagine a security consultant or a security service saying, hey, we've done a teardown of this important PLC, and here are the statuses of different vulnerabilities in there.
So our benefits are clearly we're saving money. So if I can automatically say to my customers in an automated fashion, machine readable, I'm not affected, go and talk to somebody else, then my hotlines obviously won't be swamped by calls and my tickets, my ticket numbers aren't rising up, and I can do the work. I can even say to customers, hey, I'm aware of the vulnerability, bear with me, I'm analyzing it, put out something that says, hey, I know about the vulnerability, and we are currently investigating the following products. So that also reduces the human workload on both sides. So you don't have to call your vendor anymore. If you have a clean asset inventory and you know what you have actually, so that's important, then you can actually automatically match the incoming machine-readable security advisories and VEX documents. So just to show you those that really are important to you.
Now, Thomas, this VEX idea sounds amazing. But to implement it, I'd have to spend I'd have to use 19 different specs, right? There's no one specification, there's no one data format that can do all this great work, is there?
There is actually one, and it's called the Common Security Advisory Framework. I had the honor to be one of the editors of that specification, and it really does two things. It specifies a machine-readable format for security advisories, and a VEX is basically a negative security advisory. Telling that something is not affected is basically the same like telling something is affected and putting a not in between. And it also standardizes the way how to distribute security advisories. It was built already with automation in mind, and it comes with a standardized tool set so that you can actually say, hey, that's the function that I want to have. Where are the tools that fulfill this function? And they can claim conformance against the standard, making it easier for you to find tools. It also has guidance about actionable information, what needs to be in that field so that I, as a user, can use that. If you have heard of CVRF, it's the successor and it's ready to use.
So how does VEX play into this?
It is a profile in CSAF. It specifies additional mandatory fields, and therefore it can use the same infrastructure and the same systems. And it is not mandatory to have SBOMs for VEX. You can just have the VEX and put that out without an SBOM. But
we should probably all use SBOMs just to be safe, right?
Yes.
Yes, okay, good. So what do we need to do for this? We don't need that much information, and Tom's going to break down, but essentially, VEX is about a product. It's linking a product, a vulnerability, and then the status. That's all it is, right? It's pretty straightforward. Now, if we're going to sort of break it down into fields, well, I need some metadata. I need some way of specifying the product. And then I need some information about that vulnerability. Is that complicated to do in the JSON?
No. It's fairly easy. As this is a technical talk, you have to see some code up here, so bear with me. So basically, what do we have here? we have some information about the VEXed format. So it's a CSAF profile and a CSAF version. Then we have the author and the role. That's the example company product search. It's a vendor, so you could also have the coordinator of that issuing something, or a user even telling you, hey, I have looked into that. So it's the community approach. I've looked into that. You don't have to worry about it. So then each VEX has an identifier, so that when we talk about that VEX from example company, we can actually say it's the VEX with that specific identifier. And then we have some old timestamp information so that we know what has changed during the within the revision history, and what's the current version, and when was it originally released. So now it comes to the fun part, and that's the product tree. So a product tree might seem a little bit difficult when you see it the first time, but it's actually pretty easy. A product tree specifies every product that is used later on in the document. And that's really to help with matching, since then you only have to take the product tree object, match on that on your asset database or on your SBOM database, and then whatever you get back, you can link it back to the advisory. You will have a human-readable product identifier, and it's basically what a human would call that product. And then you have something to reference that within the product later on, and you basically build up a structure. In that case, we're having a vendor saying, that's my product ABC, and that is product version 4.2. And having that structure, it makes it easy for you to match that against an SBOM or an asset database.
So let's get to the fun part, which is the product status.
Yes. So as Allan has said, we have two basic statuses here. The not affected, if you say, hey, I'm not affected, you should probably tell the people why you think you're not affected. So that's what we call an impact statement. And if you're affected, then you should tell about the action the people have to do to actually verify or patch or whatever they have to do. And that's the action statement. So if it's fixed, you're good, nothing to do, so no further information required. And if it's under investigation, then we expect you to provide an update later on, when your investigation is finished, to actually say whether it's affected or not affected. But other than that, you don't need to have any more information in it. Now, if we talk about vulnerabilities, we need some vulnerability identifier, and this can be a CVE, which we support and also encourage to use. But if there isn't a CVE yet assigned, you can also have another identifier in there. You should describe what the vulnerability is about, and that can really be the simple plain CVE description. And actually, that's the fun part here, telling about what the product status is. In that case, it's not affected, so we have an impact statement, and it says, yeah, the class with the vulnerable code was removed before shipping, so you're good. If we want to link that to an SBOM,
And of course, we want to link it to an SBOM.
there's something called a product identification helper. And that really helps you to link that and do the matching to your SBOM database, in your asset database, whatever you have connected to that.
What if I'm good enough with SBOMs that I actually want to know what the vulnerable part of the SBOM might be?
So that's also possible. You can link it to an SBOM component. There are two main formats for SBOM, CycloneDX and SPDX. CycloneDX calls that link a BOM link. SPDX doesn't have a funny name for that, so it's just a specification how you create that link. And those links are actually valid examples from the SBOM examples, so you can see which ones are referenced there. So what do we do with the justification?
Well, so this is where we're trying to sort of really enhance the machine readability. Right, it's one thing to say, I'm not affected, but especially in the short run or for new suppliers, people are going to want a little more information than that. And again, Having text in a data field is always nice, right? A tool can extract it and present it, but we want to try to help minimize the number of people that actually need to pay attention to something. And so we've developed machine-readable status justifications. This is pretty fresh. We're going to have the documentation on the CISA website, cisa.gov/SBOM, hopefully by early next week. But essentially, there are 5 machine-readable categories. And this isn't meant to be complete, to cover everything, but it's to really help an organization understand why something isn't affected. So the first one is just very simple. Hey, there's a vulnerability in a component, but guess what? That component isn't in my software, right? You're worried about log4j, my product's in C, go away. Right? That's going to be a very helpful thing that we know for a fact a whole bunch of people wished that they had at machine scale last December, when many of our holidays were ruined. CISA was asked to provide a list of all software that was affected and all software that was not affected. Those of you who are good at set math will know that that was actually a pretty tall order to do. So having this would be very helpful. And then you can say, you know what? Yes, I'm using that component, but guess what? The relevant code isn't in my project, right? So if the bits aren't there, bad guy can't do anything. Thomas used the example of Heartbleed, right? Depending on how you measure it, OpenSSL version old.old had between 600 and 1,000 different function calls you could make. 2 of them called the heartbeat function that allowed an attacker to read randomly from the web server memory. So if you were only using, a random other function, the PRNG, then if your compiler actually stripped out that code, you want to be able to tell your customer because it's simply impossible for someone to exploit that. Then we get to some of the more nuanced ideas, where the vulnerable code cannot be controlled by the adversary, or it's not in the execute path. So one of them is just to say, hey, this code is over here, and the adversary simply doesn't have any input that it can make at that portion of my execute path. This is something that is often used in existing binary analysis tools, static analysis tools. And similarly, not in the execute path. Right there, the function calls to get that simply are impossible. Right? It requires an error that's driven by a hardware model, a hardware error, and that's something the adversary can't control. And then lastly, we have the idea that, yeah, I'm using the function, and yeah, the bad guy could do it, but inline mitigations exist elsewhere, right? I'm using something that allows a NOP sled, but I sanitize my inputs somewhere else, so we don't need to worry about it. Now, what's great about these is an organization can choose which ones it wants to trust automatically and which one it wants to trust with actually having a human in the loop. And this is going to come also from a supplier. I've been told by, for example, a couple of hospitals, there are medical device manufacturers that we're simply never going to trust because they've told us that they're not affected in the past, and they were affected, and it was not even patchable, right? So, we had to actually do so. So that's okay, right? There can be risk-averse organizations that say, we're simply going to demand a patch for everything. What we're trying to do is create an environment, an ecosystem, where we can enable this kind of trust. So I think we've solved this problem.
Totally. Yep, we got it. So what we have is we have the vendor vulnerability management at one side, and we have our transport mechanism, so the security advisory, and then we have the customer vulnerability management. And if we look into that with VEXed, basically we use the same format which we use for security advisories that are machine readable, so the CSAF format, distribution, and retrieval mechanism. And then it comes to tools that can assist, and the standard specifies tools for that. So basically, an author system for CSAF documents, that's a CSAF content management system. And then on the customer side, you have a CSAF asset matching system that gives you only those CSAF documents that are relevant for your environment. And then, obviously, as a vendor, you want to have a CSAF SBOM matching system as an intake, so that your suppliers, when they supply you with CSAF documents, you can filter them based on your SBOMs and the products and the libraries that you have in your product. So it's scalable and pretty easy.
So we are starting to implement this today. Some of you are aware that the medical device community has actually been, globally, has been one of the leaders in thinking about software supply chain transparency. And so they have already been working on generating VEX documents for blinking boxes that keep people alive. There are a couple of folks in the ICS space who are getting paid, right? It's one thing to say, hey, it's an open source project and there's some people writing code. But people are actually paying to produce VEXes today in the industrial control system space. Why? Because patching in the ICS space is very complicated, often involves taking things offline, that people really don't like to take things offline. So anything you can do to help people understand what's really at risk is going to be beneficial and actually create real dollars and cents. And of course, the government is stepping in. Some of you, I'm not going to belabor the recent US government executive order that came from the White House. One of the things it did was it called for software bill of materials. The US government formally defined what a minimum software bill of materials is. And then one of the pieces in that original document that came out last July was this clear specification for future work, not part of the minimum elements, but something that was on the US government roadmap was to explicitly address vulnerability and exploitability. It called out the idea of VEX, and guess what it recommended VEX implementation in?
Let me guess. CISA.
CISA. So, what are some of the next steps here?
So basically, the automation and retrieval mechanisms, we can use them from CSAF. So security advisories today heavily rely on a pull mechanism. So you, as the customer, go to your vendor and retrieve those security advisories. But there might be an idea that you actually want to push out those things, that all of your customers got those things, so that you actually take the burden off of your hotlines. So that's a question probably whether we allow push mechanisms there. There's something, how do we do aggregation of that? CSAF has a mechanism for that. And then it's still the question about trust. Do we trust? Whom do we trust? And how do we ensure that trust along the distribution mechanism?
We also want to make sure that we're not requiring new people to get new tools. So organizations already have vulnerability management processes, vulnerability management tools. They pay money to vulnerability management vendors. Some of you have seen the very convenient Tenable sign across the river as you're walking here, right? What we want to try to do is help people say, let's integrate this into existing tools. SBOM turns on your warning dashboard lights. VEX helps you turn them off. And as Thomas mentioned, right, we need to sort of think about how do we start to integrate trust judgments and ultimately have this as policy enforcement. We also want to make sure that this data connects to the broader vulnerability ecosystem. This is one of the hardest parts of all security, is the plumbing, right? It's the making sure that we can match things together. Thomas already talked about how, what we can do today is we can link it to SBOMs. We can link it to SBOM components. But all of those require pretty stable and scalable software identifiers. You know what we're not that good at today?
Unique product identifiers.
Unique product identifiers. Hell, even non-unique product identifiers would be a better word we have today. So there's some hard work that we have to do.
Yeah, so it shouldn't be too hard to convince companies to use VEX once you understand what it really brings you and how much money that can save you. But we need to facilitate the shift in culture, really from the vulnerability compliance, so I patch everything that is out there and might potentially affect me at some point, to actually I patch those things that matter. We need more tools to assist with generation of VEX, probably also build that into our existing tool sets, and especially with the consumption. And Allan will solve the problem of unique product identifiers, so don't worry about it.
Stay tuned for some fun things from CISA coming over the next year or so, including a chance to weigh in on why existing solutions are terrible, and we want to hear from you about how your single great idea will be able to solve this problem of unique identifiers. So, we want to sum up so that we have some time for questions or to dodge some thrown fruit. Basically, we've got the idea that number of vulnerabilities discovered is rising through a variety of reasons. We welcome more security researchers. We have better tools to find them. There's greater attention being paid to open source components in our supply chain. And of course, that jackass who keeps talking about SBOM is going to make the problem worse in the short run. Not the problem worse, he's going to highlight the things that we need to fix. And of course, the idea that we keep coming back to, which is not all vulnerabilities actually put people at risk. So what should we be doing?
So first of all, you should ask your vendors to provide VEXed documents, as it really makes your life easier. And then you should start with clean up your asset inventory. So machine readable, machine security advisories and VEXed documents require you, if you want to match something, to have actually something to match at. And that's the asset inventory or your SBOM. The SBOM is already machine readable, so make sure your asset inventory is as well. And whatever you do, even if you don't like the talk today, which I can't imagine, but spread the word. So we put some hashtags in VEX, OCSAF, and SBOM.
Don't Google CSAF, use OCSAF, and don't Google why.
So yeah, that's it.
So more information, if you want to know about the broader VEX community, CISA.gov/SBOM. We have an open international working group. It's cross-sector. We've got folks from ICS, from big IT vendors, from small IT vendors, a couple of random consultants that just seem to delight in throwing bombs. It's a great community. We meet at 10 a.m. Eastern US time, which is very early for California, and cocktail hour for Europe. And once again, we're just not very nice to our friends in Japan. We're sorry. So you can find out all the information about CSAF at csaf.io. You can join the technical committee. You can read the latest drafts for comments. What's the current status on CSAF drafts?
So we passed last night the community specifications 02.
That's fantastic. That's great news. I think that's worth a round of applause.
And that's basically the next step. So that's stable, and you have the next step, the OASIS standard, which is basically only 60 days of public review, and then we got a stamp on it.
That's fantastic. And of course, if you want to know more about the broader SBOM world, please reach out. We're very interested in working with you, with your organization. We're happy to give a briefing to your PCERT team so that you can get on board with essentially the future of transparency and how to manage risk. So with that, I think we have a few minutes for questions. VJ. Oh, and over here, and Art. Getting heckled by our own FFRDCs.
Yeah, I just want to mention we are in our advisories, we are trying to support CSAF. We've been working on it. We've been working on basically getting advisories inside and producing CSAF. There's few lessons learned. I think the biggest concern we still had that you mentioned already, Thomas, the transition from today where we are and try to get CSAFs out for current products. The product tree is quite unrealistic for some people to build. So many of the vendors have a hard time even filling the CVE product needed affected. So that's one area that has been challenged that I'll honestly say. Apart from that, it's a great idea. We are fully supportive of it. We use it, and our APIs now provide access to CSAF documents.
Thanks.
We had to put kind of unknown things in there because of the product tree challenge. That's all I have to mention.
Okay.
You want to respond quickly to that?
So yeah, we know that the product tree is a challenge. We also know that it's necessary to tackle the challenge if we want to proceed with machine readability. And
we talked about the challenge of software identity. That's one of the challenges of CVE is while it is more flexible to allow data input, it has the similar complement that is much harder to parse it on the consumption side. Yep.
Sorry, hopefully very specific question, and I probably should know the answer, but could you describe the difference between the status fixed and affected? So not the reasons for not affected, but so I couldn't understand fixed versus affected plus action. Thank you.
Yeah. So if it's already fixed, the vulnerability isn't there anymore. If it's affected, you still have to do something to reach the status fixed. And if it's not affected, the vulnerability wasn't there.
So the goal is to help someone realize just sort of the status. So I think it's important to not conflate the I was never affected and an earlier version was affected and this version is not.
Yeah, I think I have some questions about the time dynamic, but I'll bring those up in our discussions. Thank you.
Fantastic, thank you. Crow.
Art made me have a second question now, so may I have two? I'm thinking of these
I'm blinking
questions.
red, so they gotta
They're
be
be quick.
yeah.
From a vendor perspective, is the intention that the vendor's going to have to be constantly pushing data out through a future API to as I go from affected to fixed? Is the intention the vendor needs to keep jiggling that? And
So basically, if it's not putting out VEXed document for every CVE, which are obviously not affected. If you have a version that was affected and you provide a patch, and now that new version, that patched version is fixed, you should inform your customer about that. So I would expect you to update that information.
okay. And then is the intention of the under investigation, so at that time, P-certs generally aren't going to have an advisory ready because they might have just had this disclosed. So the intention is they push out that information through VEX, it's under investigation, and then at some subsequent date, they provide a more richer explanation.
Exactly, it's a way of letting your customers know that your P-cert's on the case. Thank you all, and again, please get in touch if you have further questions or comments.